Hi, welcome to Chapter 10. Chapter 10, we're going to introduce you to how to write to files, how to read from files. Basically, so up to this point, we've created arrays, we've created different types of records. Now we're going to actually store them somewhere else that we can then utilize later on. So the first part of this chapter talks about a lot of the different software packages out there that do different types of file writing and reading. We have word processors, we have image editors, spreadsheets, games, web browsers, just to name a few. And so this first part talks about, okay, so we've got our hard disk, or we have a thumb drive, or we have some type of storage device. And so in this case, we got three variables. We got pay rate, employee ID, and we got employee name. And so we need to write those to a file on the disk. Now each one of these is not so much a variable, but it's also what's called a field. We put fields together, they make up one record. So in this case here, we have one record of an employee that shows the employee name, employee ID, and their pay rate. And so we go ahead and write that record to this particular storage device on disk. And then when we need to read it, we then basically go in and say, okay, I need to grab this piece of data right here and put that into the variable employee name. I'm going to read this piece of data right here and throw that into employee ID, and then read this section right here and throw that into pay rate. We'll talk about how we can then split those files out. How do we get individual fields? So when we read from a file, one thing we have to do is we have to open the file, then we process it, and then we close the file. So once we've read it, then we basically, or once we've completely processed that file, we close it. The main thing the point I want to get across is you have to open it, and when you're done, you do have to close it. Okay? We have different file access methods. We have what is called direct access, and we have sequential access. Probably the best way to explain this is a CD is what's called direct access. If you want to play song number 3, you hit the button for number 3, and the reader goes straight to that particular section and reads that song. If we had a cassette tape and I wanted to play song number 3, I'd have to fast forward past song 1 and 2 to get to song number 3. That is what's called sequential. I have to read 1 and 2 first to get to number 3. So here's a couple of different file. So when we write files, we basically use the extension. So a DOC is a Word document, a TXT is just a text file, a JPEG is a picture file. And so those extensions then tell the operating system what software is going to be needed. Now, when you first install your operating system, some of the things that are installed are the default extensions. What does it do when it comes across a TXT file? What software is it going to open? So the very first thing we have to do before we actually open the file is we have to declare what the file is. Where's this file located? What's its name? And then we can open it. So we declare output file, customer file. The word output file indicates the mode in which we use the file. So what we're telling this program is we're opening this file for output, meaning we are going to be writing to it. If we open it for input, we're just going to be reading. The name customer file is the internal name. So think of so right here I've got customer file. That is the variable name for the file we're opening. And then I say open customer file, and that's where I would give the path. So right here, customer.dat. So what we're telling the computer is, this is where that file is stored. Now you'll notice there's nothing in front of customer.dat, which means that file exists in the same exact place as this program. So then when I want to write to a file, I just say write customer file. In this case, I'm just putting double quotes around some text, and that's what I'm just writing it. So this is one record basically. Or I could say declare string name equals Charles Pace and then write that customer file name. So write that. So I can write a string literal with the double quotes around it, or I can create a variable and write the variable to that. And then when we're all done, before we end the program, we have to go in and close that customer file. So here's program 10.1. The very first thing we do, we need to declare our output file. We open the file and we tell it what file we're going to open. We're going to write that, then close the file and end. Okay. So let's take a look at it in Raptor. So before I get started, I'm going to open up this Philosopher's DAT. You'll notice that it is empty. And then I'm going to come into here, and now there is no so basically what we're doing is we declared our file right here. So we're calling my file is going to be the philosophers.dat. Now notice that in my file here, it's in the same exact place as the program itself. If I had it in a different folder or a different path, I'd have to make sure that I would put that into put that whole path name into this particular item right here. I'd put the entire path right there. Now with Raptor, to basically just to let it know that it's going to be an output file, we have to use this redirect function. So I say redirect output my file. So I'm just told Raptor I'm going to be writing an output file. And then when I say put, instead of writing that out, it's going to actually put it to that my file. So I say put David, put Edmund, and then I go ahead and say redirect output false. That closes the file. So let me go ahead and put a comma right here and say we're going to open the file. So that's where the file is open. So now, since we have it open for output, when I use the put statement, it's going to write it to the file. Now we've seen the put statement in the past in Raptor, but in this case, since the file is open, we're going to write to it. So I run this, and it gets done. So nothing in the output, but now when I come over here and open up Philosophers, you'll notice it actually wrote those three names to the file. Okay. Now, when we take a look at a record, there is actually, in a text file, there's a end of file mark. It's kind of like in Word when you hit the Enter key, it puts that paragraph mark. Well, the same sort of thing happens in a text file. It puts an end of file, it puts an end of record indicator, or end of file in this case. Okay. But at the end of the file, there's an end of file indicator. So we're going to see here in a second that when we read when we read a record, we can actually say, have we hit that end of file marker? So we can actually test that. So this is basically what it looks like right here. So we typed this John Locke, and we had a delimiter, which is basically going to a new line. David Hume, a delimiter. Edmund Burke, a delimiter, and then we have our end of file marker. Okay, so let's talk about reading from a record. So we've got declare input inventory file. So there's our inventory. We then open it. Okay, but notice it says declare input file, meaning we're declaring it for input only. And then when I say read, I just read that particular item into a variable. So I read that record, that file name, and then the record name, which is a variable, and I read it into that. And again, when I get done, I have to make sure that I close it. So this is what it looks like. I declare the input my file. I declare string name 1, 2, and 3. I open my file, philosophers.dat. I read into name 2, to name 3. I close the file, and then I display all three of those different names. So let's take a look at it on Raptor. And let me open up program 2. So I open up program 2, and again I created my file called philosophers.dat. We just wrote to it, so we know what it is. I've created a name 1, 2, and 3, a string, and then I redirect input. The other one said redirect output. This is now redirect input. Now when I use a get, it's going to read from the record. So the get and the puts are kind of in a different situation now, meaning when I have a file open for input, when I use the get, it's going to read that record as opposed to reading from the screen. And then I go ahead and close the file by saying redirect input false. And then I put name 1, put name 2, put name 2. Now notice that we used a put in the last program. It wrote to the file. Since that file's closed, we go ahead and put to the screen. So I'm going to go ahead and run it. And there it just, so basically read each record into a variable and then wrote those out to the screen. Okay. So basic read, basic write. These are very, very simplistic. What we've done so far is very, very simplistic. So, same exact thing. We had our read position. We read the record till we hit a delimiter. We read the next record. We then went to delimiter. So here's how it works. So when we first open the file, our read position is sitting right here. We read the first record. It hits the delimiter and stops. Our read position is sitting right here. When we go to read the next record, it reads till it hits the delimiter and stops. So after it read the second record, that read position is sitting right here. And then when we get to read the third record, we read, and we didn't even look at we're just assuming there's 3 records. We just read, that's all we did. And then basically the read position was sitting at the EOF right there, end of file indicator. Now let's talk about appending. So we can declare an output file as append, meaning, because here's what happens. When I create an output file, it creates that file from scratch. If one is existing, it completely wipes it out. But what if I don't want to do that? What if I want to open an existing file and start appending at the very end? Well, I can open a file for append. So here's this file, Joe, Rose, Greg, Jerry, and Renee, and then I go ahead and open it for append, and I write Matt, Chris, Suze, and then I close the file. Well, then here at the end of those names, we now have Matt, Chris, and I don't know why they got Renee and Matt together, but they should have addressed that in their book. So now we're going to use loops to process a file. Okay, so remember, we have an end of file indicator, so we can determine when we've hit the end of file. So I can keep reading until the end of file comes into play. So let's just open up 10.3. So 10.3, I declare a variable, it's an integer called numDays, a counter, set it to 1, sales, set it to 0, and then I create a variable called sales file, and I set it up to sales.dat. Okay, for how many days do you have sales? And I get numDays, and then I redirect the output file to sales file. Okay, so I'm writing it to output. This is get the sales for day 1, get sales, and I keep doing the counter, and then I redirect the output, so I then close the file. So let me go into that file to make sure it's empty first. It's called what? It is called sales.dat, and I don't think I saw sales.dat, so that's good. So let's go ahead and, so that does not exist right now. So let's go ahead and run it. So how many days do we have sales? I have sales for 5 days. Sales for day 1. I'm just entering some random numbers here. So we basically got done there. So now if I go over here and look, you notice I now have a sales.dat, and if I open it, I see absolutely nothing. Why did that happen? Let me get back to you. What did I forget to do in this program? I'm getting the sales, but I'm not doing anything with it. I need to put the sales. So I need to basically put an output statement right here and say sales. Okay. So now let's see if it works again. So let's try it one more time. 5 days. Let's make it 3 days. So then I'm going to put in, let's see, 236.5, 654.8, and 752.12, and we get done. Okay, so now let's go out and look at our sales file this time, and yay, we have data. Okay, now what I could have done, since we're talking about, I wonder if the set precision would work here. Let's see if it does. Okay, I'm going to put my set precision right here. So that's a call statement, right? Well, you know what? I don't need to put it there. I can actually put it up here before the loop. Okay. But it's going to screw up our counter now. The counter is going to say 1.00, so on and so forth. That's fine. So run it again. Let's say 3 days. So here's day 1.0. That's fine. That's fine. $456.13. So now you notice if I go out here to the sales, basically it rounded out to 2 decimal places, which is what we wanted. Okay. So we looped through a program. We asked how, so we had an indicator of how many days, basically how many times you want to loop through this program to get the sales. So then we're going to read a file and loop and detect the end of file itself. So let's take a look at that. And there we look at, is that program 4, 10.4? So we open up sales.dat. We then create a variable called sales, set it to 0. We redirect it as input, so we're going to be reading it this time. And then we're going to say, here are your amounts. And again, we set, looks like we set our decimal place to 2 there. Now, here is a indicator that's built into Raptor called end of input. And it basically says, have we reached the end of input? If we have, we're going to drop out of that loop. If not, we're going to get sales. Okay? We're going to put sales out on the screen. So we're going to get it, and then we're going to write it out on the screen. And then here at the end, again, the last thing we do is we close that file. So I run it. And there's those 3 different variables that we typed in the last one. Okay. So here's our first in the spotlight. So Kevin is a freelance video producer who makes TV commercials for local businesses. When he makes a commercial, he usually films several short videos. Later, he puts these short videos together to make a final commercial. He's asked to design the following 2 programs. A program that allows him to enter the running time in seconds of each short video of the project. I'm going to save that to a file. The program that reads the contents of the file displays the running times and then displays the total running time of all the segments. So here's our algorithm. We need to get the number of videos in the project, open the output file for each video in the project. We're going to get the running times. We're going to write the running times to the file. Okay. So here is 10.5. So we create our video file, which is video_times.dat. We We got a variable called num videos. Our running time is real, set to 0.0. We've got our counter set to 1, and then we ask the user to enter the number of videos in the project. Then we redirect this as output, so we're going to write this to an output file. We then loop through. We're going to loop through how many videos that we are going to basically produce. Then we enter the running time for each video. We put that to the time, add that to counter, we keep looping around, we get done, we then close that file. Okay? So, do I have a video? No, I do not. So I'm going to run this. We got 4 videos, and we'll say it's 56 minutes. We'll say 46.3 minutes. It's 78.2 minutes and 12.6. Okay. So now if I go out here, I should see, yes, we have a video times DAT. So now what do we need to do is in 10.6, we now need to read those. So now we're going to create, so we create our variable for video times.dat. We create our running time, we have our total, and then here are the running times in seconds for each one. And then we redirect this as input, and we read the file. And again, we can use the same end of input, which is our end of file indicator, to determine whether to get out of this loop or not. I get the running times. I then put the running times, I display them on the screen, I add that to the total. And we're going to keep looping around until we basically hit the end of input. And then we're going to redirect the input as false to close the file, and then we're going to display the total. So I run it. So here are the running times, and the total is 193.10. Now I would have probably wanted to go ahead and set a precision in there. I probably would like to have done this. Oh, probably to just 1 decimal place. So when I run it again, yeah, everything's got 1 decimal place in. Okay, that's good. That's good. Okay, so this next section talks about how to use files and arrays. So we've created arrays. How do we take an array and basically then just write it to a file? Well, so here's an example they have. So we've got our constant integer size 5. We create a numbers array by the size of 5, and we go ahead and initialize it with 10, 20, 30, 40, and 50. So we've created an array, we've loaded it. So then we come in here and we create a variable called index. We declare an output file, number file. We go ahead and open the number file, which is values.dat. So we've created the file, opened it. Now we say for index equals 0 to size minus 1. So again, remember, Raptor, we would just say basically do this until we basically are greater than size. But here we have to do size minus 1 because remember the indexes are 0. They start at 0. So if it's 5, it's going to be 0 through 4. Okay. We write the number file, and we're going to basically write that array element to the file. We're going to loop around. We're going to do that for each array element right to the file. We get done. We close the file. And here we're going to reading. So we're going to basically do the same thing, except we're going to read. So we got a constant integer size 5. We declare our integer numbers file. We declare our index 0. We declare our input file, number file. We open the number file values that, so we open the number file. So we declared it as an input file, so we're going to be reading it. So while the index is less or equal to size minus 1 and not end of file, we are going to write the number file or index. Oh, I see what we're doing. So we're going to read the file. we're going to read each record and put it into the array. So okay, so we're just doing the opposite we saw above there. So the first one, we created an array, and we read the array and wrote it to a file. Now we're reading a file and writing it to an array. Okay, so vice versa. Okay, so now we've dealt with pretty much one field at a time. Now let's deal with an actual record where we actually put fields together and make up one line of a record. Okay, so we write our employee file name, comma ID, comma department. So that's how they're basically saying to do it here. I believe Raptor may do it differently. We'll see here in a second. So I open up Raptor, see, so I've got my name, I create a name variable, it's a string, ID number set to 0, department set that to null value, it's a string, num employees set that to 0, and our counter equal to 1. We create an employee file, employees.dat. How many employee records do you want to create? We're going to get that number from the user. We're going to redirect the output to the employee file. So basically we're saying we're opening this up as an output file. We're going to loop through this how many times that you said we wanted to create for employees. So we get the employee number, we get the employee ID, we get the employee department, and then we say put name, comma, ID, comma, and department. So basically it does the same exact way. Notice I'm using the concatenation symbols, the plus sign, and I'm putting double quotes around the comma. So when it actually writes that record, it will have actual commas between each field. Then I redirect the output, false, close the file, and then I put employee records written to the employee file. Okay, so create this. How many records we want to create? We're just going to create 3. And it says, what is the name employee 1? It's Bob. ID number is 11111. And their department is accounting. Next one is Sue. ID number is 22222. Department is systems. Employee 3 is Jill. ID number is 33333. Department is marketing. And click OK. And when we get done, we're going to check to see what the employee file looks like. Employees.dat. So I look at employees.dat, and there I have Bob 1111 accounting, Sue 22222 systems, Jill 33333 accounting. Works great. Okay. So as you can see, really nothing real fancy there, because all we're doing is just putting the fields together separated by commas. But those commas are very important, because those commas are going to determine where one record starts and where the next record ends, or where one record ends, the next record starts. So let's basically continue on. Now let's read those records. So let's go to 8. Let's see how we read those now. So I got my record. I got a name, and record's a string. Name is a string. ID number is an integer. Department is a string. Employee dat. So we're going to basically then redirect input. So we're going to be reading the employee file now. So we're going to read this until we hit the end of file input. So the end of file indicator will tell us we've hit the end. We're going to substring record, name, ID, and number. Now, this is a procedure I had to write that basically is going to read this file. So let me see if I can kind of remember how this works. So it's going to read each record, and then it's going to go character by character until it finds a comma, and then it will basically say that's a record. Then it will start one past the comma and read until it basically hits the end, or the next comma, and basically continue on that. So I got field 1, field 2, field 3, I got position 1. So basically we're starting position 1. So I got par in position 1, par in position 2. So here's what I've done. is parm position 1 is the first comma, parm position 2 is the second comma. So I'm assuming there's only going to be 3 fields for this. Okay. So I'm going to loop position. So if position is greater than size, if it is, we're going to drop out, meaning the size of this, the size is the length of the entire record. Okay. So once our position is greater than that, we're done. We're done with this guy. We're going to drop out. So I come in and say a string position, comma. Does it equal to comma? Yes. I come in and I say parm position 1. Is parm position 1 greater than 0? If it is, we're going to say parm position 2 is now the position. But if parm position hasn't been set yet, because up here I set it to 0, then I'm going to just make parm position 1 that position. Okay. So all that does is set those 2 positions, and we continue on through the loop. We increase the position by 1. We come back up and say, is it equal? Okay. So that's all that loop is doing, is figuring out where each comma is. That's its only job. This next one is we reset the position. We come in and say, if position is greater than parm position 1. If it is, we're going to drop out of that loop. If not, we're going to say field 1 equals field 1 plus a string position. So a string position is so it's taking each character and kind of adding them together, concatenating them together, and creating field 1. Then we go in, we say parm position is set to parm position 1 plus 1. So we're starting at the 1 past the comma. And then I go in and I say parm position. So once parm position 2 is greater than or equal to parm position 2, we're done with that field. So we're going to do the same thing. We're going to grab each character, load them up until we get to field 2, and then we're done. And we do the same thing. We start 1 past parm position 2. We go into our loop, and we do the same exact thing. We take each character until we hit. Here we're looking at positions greater than size. Once we get that, we're done. So when we get done here, so what we're doing is this. We're bringing in the A string and the parameter, and we're passing back field 1, 2, and 3. Okay? So down here, when we get done with this particular call, we are now going to have name, number, ID number, and department. Now notice I called it name, ID number here in department, but over there it's field 1, field 2, field 3, because remember, it doesn't care. It doesn't care. It just knows that I'm passing in a variable. I don't care what they're named over there, but I don't care what they're named over here. But it's going to, when it passes back field 1, so that's the first one, it's going to go into name, and then ID number, and then department. Okay, so let's go ahead and run this and see if it's going to work. And there it is. Name Bob, ID number 11111, Department Accounting. Name Sue, ID number 22222, Department of Systems. Name Jill, ID number 32233, Department Marketing. Okay. Now, we don't have a substring function, so we had to create it by hand. If you ever need something like that, you can go ahead and utilize this one. I'm actually trying to develop one that will determine how many commas there are automatically, and it'll be a substring that works pretty well, but I'm working on that right now. Okay, so you kind of get the gist of what's going on there. We read a record, we determine where the commas are, and then we basically, now most of our programming languages don't have to deal with that they can deal with those things natively, but this is a great practice to basically get down to the nuts and bolts and figure out where things are within a string, or within a record in this case. Okay, so if you're a programmer for a company or organization, you'll most likely have to write programs that read data and files directly that already exist. The files will probably be stored in the company's servers, whatever the case may be. And you'll basically have some type of a documentation that will tell you what type of file it is and what the fields are, the lengths of the fields, basically all that type of thing. So here's a new spotlight. We've got Midnight Coffee Roasters, Inc. There's a small company that imports raw coffee beans from around the world and roasts them to create a variety of gourmet coffees. Julie, the owner of the company, has asked you to design a series of programs that she can use to manage her inventory. After speaking with her, you have determined that the file needed to keep the inventory records. Each record should have 2 fields holding the following data. Description. A string containing the name of the coffee, quantity in inventory, the number of pounds in inventory as a real number. So let's take a look at 10.9. And so notice I've got a 2 upper. Looks like I'm going to basically be grabbing the 2 upper. That we've seen that before. Again, that's just something you can actually grab this guy. You can actually just, you don't have to grab the 2 and the start and the end, but grab that and click copy and paste it into your particular program. And what you need to do is make sure that you have a string that's in and out. You have to pass it in and pass it back out, because you're going to be passing in as mixed case, and you're going to pass it back in this particular item as 2 uppercase. Okay. So I got my description, I got my quantity, I got my number of employees. Do you want to do another? Yes or no? I create my coffee file, which is coffee.dat. I direct it as output. So I'm going to be writing to output. So here's my for loop. Do you want to do another? Yes or no? So I'm going to do this until do another is not equal a capital letter S or Y. Okay? Right now it is a capital letter Y. When I come in here, I'm going to do it until it's no longer a capital letter I. Remember, this is a until loop. So, I don't know why it's called a for loop. That should be a until loop. Okay. So, we get the description, we get the quantity, and then we go ahead and put those together. So, we've got this file open. When I do a put, it's automatically going to write it to the file. So I'm going to write it with a comma between them. Do you want to get another? When I get the other, I'm going to send it over to upper to convert it to uppercase. Make sure it's uppercase and then come back. Okay. Once we're done with that loop, we're going to redirect the output as false. We're going to close the file, and then we're going to say data appended to coffee file. Appended. I don't think we're able to append here. I don't see that. Well, let's see. Do I have any coffee data right now? So there is coffee data in there. So if I run this, will it wipe it out? Enter description. Then ask a quantity. Did I? Oh, I did. Okay, I see what I did wrong. My bad. Let's check the file first, and I'll run it again. Yeah, so it overwrote it. We were not able to append. So it looks like Raptor cannot append. So let me run this again. I think I know what I did wrong. I didn't read it correctly. So enter description. Do you want to do another one? I want to put a lowercase y in here. So I'm going to put a lowercase n. Okay, now when I go over here to look, open coffee, yep, there they are. Okay, so can't do an append right now, but we are able to loop through and do this just fine. Okay. So we're going to search for a record. Julie has been using the first 2 programs. So let's do this real quick. Let us go ahead and run this again. Is it 10? No, it's 11. Is it 9? Yeah. So let me rerun this program. Except this time, I'm going to use this information. Can I scooch it over? Yeah, good, good. So I run it, and Sumatra dark roast 12. Yes. Sumatra medium roast 30. Sumatra decaf, which is 20, and Sumatra organic medium. Oh, what did I do wrong? Okay, we just got this first. That's fine. I always screwed up on that, but that's fine. We can continue on. So let me close this. And now let's reopen the next one. So it says basically, Julie's been using the first two programs you designed. Now she has several records and stored and a coffee. She asked you to design another program that she can use to search for records. Okay, so here's 1011. And so basically what she wants to be able to do is search a record. So I've got my delimiter, I've got my description, I've got my quantity. Delimiter is now notice I've got single pick marks. Pickle marks, since it's one character, you have to use single. My description is set to a null value. Quantity is set to 0.0. Here's my coffee file. I redirect it as input, so it's going to read as input only. I'm going to loop until this is not a for loop. This is an until loop. So we're going to do this until we hit the end of file. So since this file is open, when I say get, it's going to read. I'm going to use my substring to basically delimit it. That substring is just like the previous one we looked at. And I'm going to put the description and I'm going to put the quantity. And then I'm going to basically, at the end, I'm going to close the file. So let's see what it looks like. Yep, so just read each one and basically put them out. Okay. And now, was that 11? Was that 10? That was 10. My bad. So let's go back and look at 11 now. So 10 just read that file. So 11 now is the searching feature. So we want to be able to search. So I've got found equal false. So everything's pretty much the same, except now I want to say enter a value to search for. Okay. We're going to do this until the end of input file or the found is equal true. We've seen this before. We've done the same exact type of search. It's a sequential search. I've got my substring where I basically go and look for the delimiter. So I'm reading each record into a field. Okay. If my description is equal to my search value, I put found, description, the quantity, and I put found true. It drops out of that loop. And then it comes in, and basically if it says found true, we don't do anything. If not, it says search value could not be found. Okay. So I run it, and I want to make sure that I'm going to look for Sumatra decaf. Okay. So I type that in, and now it's going to basically go through the program. That says found, Description, some match of decaf, quantity 20 pounds. Okay. So I'll run it again. This time I'll just type some gobbledygook. That says that value was not found. Okay. So we want to modify a record. Julie's very happy with the programs we've written so far. Now she says open the original file for input, create a temporary file for output. So this is kind of a two-step process. We're going to open up a file. We're going to read each record. We're going to do it until we want to either modify a record, like say we want to change a record, or delete a record, or whatever the case may be. We're going to write each record to a temporary file. At some point, we're going to either modify a record, or we're going to delete a record, or change a record. We're going to put that in the temporary file. Then we're going to delete the original, and then rename the temporary file as the original file. It's as simple as that. Okay? So, we're going to open the original. So here's the algorithm. Open the original file for input, create a temporary file for output. Get the description field, each record modified, and new value for the quantity field. Write, while not at the end of the file, we're going to read a record. We're going to basically, if this record's description matches the description entered, we're going to then write to the temporary file. We close the original file, we delete the original file, rename the temporary file. It's as simple as that. So let's open up to 1012. So here I've got my substring. Okay, substring, all it's doing is separating out each field and giving it back to us. I got my rename file. So this is a procedure. All it's doing is it brings in the input file name and it's got an output file name. That's as simple as it gets. So what does it do? Well, I bring in my input, redirect the output, read each one, I put each one. So look, I'm doing a get and a put. Since I have one open for input, one open for output, whenever time it does a get, it reads a record. When it does a put, it writes the record. So I write, read, write, read, write, read, write. I then close each file. Okay? So that's not renaming now. Let's see. Oh, I see what it does. Okay, okay, we'll talk about it in a second. So here I've got my delimiter, I've got my description, quantity, so I've created those, and new quantity, and found false. Here's my search file, search value. Then I tell the user I need a value to search for. I then enter a new quantity, and then I create my coffee file, coffee.dat, I read it as input. I'm going to then create a temp file, and I redirect that as output. So open the output file. So when I go through the loop, I'm going to do this until the end of value or end of input is true, or the end of input is equal true, or end of file, or the found is true. So I read a record. By the way, if the one thing I never talked about is this get. I just put double quotes in the prompt. That's all I do, and then I say record. That's the variable. That's all you got to do for the get statement. So I read a record. I've got my substring. That's where I basically then split out the fields. We've seen that before. And then I say, does the description equal the search value? If it does, we put the description and delimiter and new quantity into the temp file, and we say found true. Okay. Else we put the description, delimiter, and quantity into the out file. Now, here's how this rename file works. I'm saying the temp file and the coffee file, what we're doing is I'm just taking each record from the temp and writing it to the coffee file. That's all it's doing. So when we get done, the temp file and the coffee file are exactly the same. That's really all that we are doing. So that's how we rename it. It's kind of a cheap way to do it, but it works. So both of these are doing a put statement, which means they're both writing to the output for the temp file. In this case, if the description has changed, we're going to change the quantity and then say found equals true. Okay, so very simple. We put in a search value, we put in a new quantity. We then search for that value. Once we find it, we change the quantity. Then when we get done, and we're writing that to a temp file, we get done, we take each record from the temp file and rewrite it to the coffee file. When we get done, the coffee file has been updated. So let's run it. And I'm going to say Sumatra decaf. And the new quantity is going to be 45. It's currently what? Let's take a look. It's currently at 20. Okay. So I click OK. And, uh-oh. Let me get back to you. Before we can open those files for input and output again, we have to do what? They have to be closed. Okay, so we have to close them first. So here's what I've done. I've closed the output file, I've closed the input file. Then I call the rename. Okay, so it should work this time. Okay, so get done. If I go over here and open that coffee.dat, we can see that Sumatra decaf is now at 45. Okay, so did you see my mistake? My mistake was I needed to close these files before I can reopen them. Okay, so that was basically the problem that was going on there. They needed to be closed before we can then reopen them to then write one record to the next. Okay. So delete a record. So this is going to be identical to the last program. The only difference is instead of updating a record, we're just not going to write it to the temp file. So if it's a record to be deleted, we're just not going to write it. So let's see how that works. It's going to be, again, they're going to be identical except for the right part. Okay? And I forgot to close the file. Yeah. Okay. Yep. So I'll make sure those are in there now. So here's my delimiter. Everything's the same. Here's my search value. Everything's the same until we get to here. Okay. If the description is equal to search value, we just say found equals true. And then we basically, if it's not, we write it to the output file. So if it's true, we're not going to write it. So when we get done with this, everything that's in the coffee file is going to be in the temp file except for that one record. Then, when I call the rename, it will basically rewrites the coffee file and it's gone. So, very simple. I run it. I'm going to type in Sumatra decaf. And now when I go out and look at that, notice that the decaf is now gone. So again, it's a very simple process. We just write it to a temp file, and whatever we want to change, delete, or whatever, we just make that change as we're writing to the temp file. Then we just in the book they talk about deleting the other file and then rename it, but we just rewrite. In our case, we just rewrite the coffee file with the temp file. Okay, so control break logic. Now, control break logic it's it's basically it's a concept where we can have multiple, so we have loops that are searching for things, and every time we have a break we need to do something. So for example, I've got stores in multiple states, okay, and I've got sales in those states. So here's store 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, and they're in North Carolina, Georgia, Florida. So what I want to do is I want to show totals by state and then a grand total overall. So I'm going to keep in my loop until the state changes, then I basically write the total for that state, but I keep continuing to do a grand total, and then basically do that until I break the next state changes. Now it's very important. The one thing I can't stress here is you have to sort by what you're breaking on. So in this case, if we're breaking on state, state has to be sorted. They have to be grouped together. So we would sort on state before we'd actually run this program. Okay. So here we've got student ID, a donation amount. Okay. So we're going to basically break on student ID. So that must be in sorted order. And we are then going to show a total by student and then a grand total overall. So let's take a look at that program. And wow. So basically I've got two calls in my main. I'm going to call print header, which basically prints the Pine Brook Academy fundraiser, and we're going to put the student ID and some spaces and donation amount, and then we're going to have these double lines to catch. So that's our column headings. That's our report heading, column heading, and then our put statement for the underlines. Okay. Come back to main. We're going to print details. So I go to details. So it looks like this is the main piece of the program. So I've got my delimiter. I create a student ID field, create a donation amount, student total, and then we have current ID. Okay. So I open up my donations.dat. I redirect this as input. So we're going to be reading this as input. When I say get, it's going to read a record. So I use my substring to go ahead and split it out into a student ID and donation amount. So I'm passing in the record and the delimiter, and I'm getting back student ID and donation amount. Now, the very first thing I do, very important with the control break, is I need to set the current ID. And I do that with the read of my first record. So I basically take that student ID and I load it into current ID. I go ahead and set my decimal places, and then I say we're going to do this until we hit the end of record, the end of file. My next loop inside of that is we're going to do that as long as the current ID is equal to the student ID. If it is, we're going to put that ID amount in the donation amount, and we're going to add the student total. We're going to add that donation amount to the student total. If the current ID is not equal to the student ID that we just read, we are going to basically then put the total donations for student and the student total. So it means we've just changed students. So we're going to display the total for that student. We're going to put a dashed line. We're then going to add the student total to the grand total amount. We're then going to set the student total to 0, 0, because that is basically getting set up for the next student. And then we're going to change the current ID to the current student. So now we're at our first student of the next ID, and we go ahead and do the next process where we go ahead and take the student ID, we print the student ID and the amount, and we add that amount to the student total. I then get the next record, and I substring it out, and it comes back around. Okay? If we hit the end of input, we basically come down and we say the student ID. So if we hit the end of file, that means we haven't finished out that last student yet. So we have to finish out the last student. So we go ahead and put the student ID and their donation amount, and we put the student total and the student total and their donation amount, and then we write down the total amount. Okay, I'm sorry. Then we have to add the student total to the grand total, and then we go ahead and display the total of all the donations and then we basically close the file. So we run it. There it is. So this is Pine Brook Academy fundraising report. Student ID, space, donation amount. There is a split. There's students 104. Total donations for that student is that. There's 105. There are donations. 106. There's donations. And total donations was $3,150. Okay. So very simple. We basically have to read a record, very first record, and then we take that break field and we put that into our current ID. And then we go ahead and process until the current ID and the student ID in this case do not match. Once they don't, then I go ahead and write the student totals. Then I go ahead and process the student donation amounts. Now, as soon as I hit the end of record, I haven't finished out that last student, so I have to print their totals. I have to add that amount to the grand totals. Then I display the total amount. Okay, I think that's it for the chapter. Yeah, so very important using files, reading and writing to. The one thing we can't do is append. We could do an append, but it would basically be writing to a temp file and then adding the one at the end and then renaming it. So we could actually do that in Raptor. But so if you have any questions, just give me a call and we'll see you next chapter.